Hey everybody, it is Brian and Mike here from Summit Racing.
Howdy.
Mike, you want to introduce yourself?
I'm Mike Schmidt. I'm with Summit Private Brands. Been here for a long time.
A long time. I myself have been with Summit for about 7 years now. And Mike and I, what we do here is create really cool engine parts for the most part, but Summit Brands, we do a lot of different things. If you're an enthusiast, car, truck, off-road, marine, power sports, we've got a little bit of everything here at Summit. But Mike and I, our big deal is internal engine parts. Specifically, I'd say really since 2018, Pro LS is, a lot of really where we started, and a lot of that cool stuff has migrated into our Pro SBC, small block Chevy, Pro BBC, big block Chevy, our Ford stuff for Windsor, and Hemi as well. We just came out with a whole slew of Hemi cams. We got 27 new Hemi cams.
A lot of new parts coming down the pipe. Yeah.
A lot of new parts. So what we're going to do here today, we were doing a lot of these live streams back in the COVID days when we had no other, way to reach customers and everybody was stuck inside and it really was terrible. Started doing live streams and just talking directly with folks that had questions about our parts and projects. And we wanted to talk a little bit about Project 1000 today, what it was, what it is, and what it will be, I guess.
Okay.
The original idea between, Project 1000 was...
Number one, it never was supposed to be called Project 1000.
Right, we just threw that name at it.
We knew it'd make way more than 1,000.
Right,
yeah.
right. So Project 1000 was supposed to be a kind of a grocery list of cool racing engine parts, all stuff out of the Summit catalog. The idea being that
all Summit branded parts out of
Summit branded
Summit shelf,
everywhere we could. Yeah. And if Summit brand did not have anything in particular, we just used the stuff that, from our vendors. A good example of that was the VS Racing turbos that we used, right? Intake manifold, I think that was ours.
That was ours.
Ours. But lots of things. We tested all of this over at TrickFlow, which is about 5 miles away, TrickFlow Specialties. They got a couple dynos over there. They do a ton of validation work. They just pour steam to these parts and they try to break them. And if they don't, they go on sale. Life is good. We had a recent part that they did 30 pulls on that was a heck of a lot of fuel that we spent to validate that part, but that's what our team tries to do here when we develop things. All right, so we've had a few people join in already. I want to say thank you guys for jumping in early. Feel free to make comments. I've got a little thing here where I can look at the screen and see the comments and do our best to answer them. If we don't have an answer, we will get the answer to you. The first is, I want to say thank you to Drag, Drive, and Repeat. And we've also got Salad dropping in. Yep, okay, cool. All right, so we're rolling already. The first question was, from Drag, Drive, Repeat, is 5th Gen Camaro SS Automatic. What performance pieces would you like to use to make it run consistent 12 O's and 10 O's in the quarter mile? Drag and Drive would be the driving style. Drag and Drive is a cool deal. You want to talk about Drag and Drive?
Well, everybody's doing that now with all the sick week and all that, and it would be just a blast to go out and do that with anything, even if you're not super fast, just having fun.
Yeah.
Take a couple days and go run one of those. But I would think a 5th Gen is a pretty heavy car, and if it's not a dedicated race car, I'd probably put a decent cam and some heads and exhaust modifications in it.
Yeah. The 12.0 and the 10.0 are completely separate things.
They're miles apart. Yeah.
Right. So the 12.0 we can kind of go with our standard package with that. You don't need heads to do that, but at the same time, you're going to need the cam and springs to do that. If you have an LS3, the cool thing about that one is it's already got a great intake manifold on it, so you don't really need to change the intake or the throttle body or the ignition, coils, wires, plugs, any of that business. We've got a couple cams. One is some 8710 R1, and another slightly larger one is some 8711 R1. And one is a 230 at 50 cam, the other one's a 234 at 50 cam. And it doesn't sound like a big spread, but they do pretty different things. We don't like to use the stage 3 and 4 thing, but we do everything incrementally, and these are the third and fourth biggest ones. And our fourth level is generally stuff that you know is going to drop in. You're never going to have fly cutting. Always check piston to valve, but it's not going to touch the factory piston. Even allows a little bit of head milling, which we're a fan of compression. The 8710, that's the 230 at 50 cam, that dude will make about 467 at the wheels, and that's with a generally like some American Racing headers or something,
Okay.
and a MagnaFlow exhaust. You know, typical DynoJet numbers, it'll make 467 and some really good torque in mid-range. 8711, that's the 234 cam. A lot of people run that because it makes great power. And it does. It makes another 6 or 7 horsepower even yet. So it'll be up there in that, you know, say 475 horsepower range. Again, these are numbers anybody can repeat. We don't inflate anything. This is as you drive it, no extra cooling down, no tricks, no fuels, no anything. This is just when you put a part in your car, you go take it to your local, you know, chassis dyno shop, which we heavily recommend doing that. You always find cool things over there. You know, the thing's just going to make the number that we say it will. So with 8711, we're picking up 7 horsepower at the wheels, which is great, except for losing 15 foot-pounds in the mid-range. And in the mid-range, I'm talking 3,500 RPM.
In an automatic car, you might want the smaller cam.
You're going to want that, if
keep
not
torque.
even a step smaller with, like, say, we've got a 222 cam and a 226 cam as well, 8707 and 8, actually.
Mm-hmm.
So we've got things for, you know, definitely, it's great to have a big cam with big horsepower, but if your torque converter is signing on at 2,500 and your engine doesn't sign on until 4,000, you're going to be sitting there waiting while that other car runs away from you at the light. So, not that we street race.
I mean, to get in the 12s with an automatic car, anything you do to lighten that thing up,
and the converter.
and a higher stall converter for sure.
You want to talk Pro LS converters?
We do have a line of Pro LS converters that should have a 6L80 in it, which we've got a 3,000 to 3,200 stall. That's a very nice billet front converter. That custom-made features on the shelf.
Right.
You know,
and priced inexpensively.
Yep.
Made in
it's
USA.
Very affordable. Made in USA. High quality.
It is nice. So one of the things about the torque converter is, like I just said, you know, if your cam is making power in 45, I mean, what engine isn't, you know, making more power at 45, right? So the closer you get to that, the better. Back in the olden days, 3,500 on the street, that was a big converter, but they weren't lockup converters.
Right. The lockup clutch allows you to
Right. And now you
run
can
the
have
stall
your cake
and
and eat
then
it too.
knock it down when you engage it. Yeah, light throttle.
Right. So now like 3 or 32 is
Yeah,
really
building the
kind of
heat,
just getting
right.
started. Yeah. So that would be, you know, one thing to definitely do is get the engine up on the cam, so to speak, with that. The other cool thing about 8710 versus 11 is it tunes out really nice. People want the choppy idle and everything, but if it gives you fits when you're trying to tune it, it gets old real quick. 8710, I got to tell you, we've got a ton of customers out there that endurance race with it. It's low maintenance, no maintenance, basically. It's hard to say it's going to last 100,000 miles, but it does that, no problem. Many people have put that kind of mileage on it by now without any kind of stress on the valve train. Another cool thing about the Pro LS cams is, yeah, we are not stressing the valve train. Mike and I have worked here long enough to know that we need to make the Lobes happy with the type of valve train that our customers are using and can afford without exotic stuff. So we've designed it around the factory rocker, trunnion kitted. If it's got any kind of miles on the rockers, the trunnions are a nice thing to have. There's bushing styles and bearings. I like the Summit bearing style. The bushing styles don't suffer catastrophic failure, but they do wear.
Then it's a controlled wear, yeah.
Yeah,
It's like a
control
bronze
wear is a great way.
is a bearing surface that wears,
Yeah.
So
there are, and people are like, don't throw trunnions in it. The reason why these kits exist is because people have blown their, you know, stock trunnions apart you got to remember, these cams are like 525 left from the factory or less. And now you're going to go ahead and force that thing to open up another 100 thousandths more than it ever did. It's wearing parts inside that trunnion that were never touched before. Inside that trunnion is a bearing on a race, and now those little bearings are hitting a part of a race that it never hit before. It's taking an impact there that it never saw in its life. So it might have gone another 60,000 miles with your stock cam, but you put in something more aggressive with more seat pressure on the springs. It is a failure point. So we do recommend the Summit in particular, bearing style training upgrades. We have sold tens of thousands of these, and we just don't hear failures, right? We've got a lot of data behind us.
It's a really good part, and
Right.
we sell lots of them.
Yeah, that's the thing, it's, Mike and I have access to the data. And that's something that we don't share with everybody, but we know good stuff and we know bad stuff. And if we put the Summit name on it, that's a pretty high bar. It's the most important thing we have is our reputation. So if we put the Summit name on something, it's because we believe in it. If it does not meet the grade, it doesn't become sold to begin with. And if we find out that there's any issues with something, we just yank it. It's not worth our reputation to sell a part, as opposed to some other people that sell parts that really don't care. And they just sell your part and take your money. So I'll just say that. First name starts with A, last one ends with an N. So, okay. Some more questions. So anyway, getting back to the 5th gen deal, boosted. We are big turbo people here, but a 5th gen, there are some kits to be able to do it. On3, if anybody has a question, and they did, about what turbo kit we put on, Project 1000. On3 is a local company to us. They make a good value line of, kits for things, and we figured we're going to be putting this thing in a 4th gen at some point, or something tight.
Something like that.
So we ordered up a 4th gen turbo kit from them. I think we got the AC compatible one.
I don't recall that. Yeah, I don't.
Yeah. Well, him and I are not really AC people, but I know a lot of people are. So yeah, it's the On3 kit was really good for us. Again, we did over 100 pulls.
Oh yeah, yeah, and we ran out of injector. We know that our customers and engine builders and racers are going to make more than that, and it is.
Yeah.
We stopped where we did. We wanted to prove that you could buy all those parts and throw them in an engine in a short block and boost the heck out of it, and it's going to hang in there and run.
Yeah.
And it did.
So you're getting into the target numbers. So we were approached about making 1,000 horsepower, and him and I are kind of like laughing, right? Because everybody, is making 1,000 these days, and you don't need a lot of the parts that we put in this to make that number. But at the same time, everything that we've got is a recipe, right? And if you can get parts from the junkyard, or you've already got them on your motor, save some money. You don't need to buy our coils, but we put it there anyway, just so you knew it. But often, just a set of, LS9 head gaskets, we do like our head studs, and then just a rod and piston deal is real safe at that number. But the question is how long, right?
Yeah.
A lot of people make this number and they're like, I made 1,200 horsepower, whatever the number is, stock bottom end. And it's like, yeah, that's a grenade, right? And a lot of people are...
Eventually they're going to break, right? They're going to drive over the crankshaft.
Right, exactly. It's like, what is your time worth to you, right? So I would say at a minimum, this engine needed to have a rod and piston. And I'd have zero issue adding another 300 or 400 horsepower to the stock crank.
Oh yeah.
The stock crank isn't a point of failure with these things. It will take out bearings before it basically cracks, the crank itself. But what fun is that when you can have a 408 for about the same amount of money?
Right.
A crank is less than $700.
Right.
Right. So the cool thing about cubic inches under something, not that you need it to make that horsepower number, but when you're actually driving something on the street, 50 cubic inches, 50 foot-pounds of torque, it's like the difference of going from a 4.8 to a 6.0, basically. I mean, you're just, it's drive around power. It's always going to be there underneath your foot. It's reliable power. And if you want to talk about it a little bit, it does lower the operating range some, which makes the valve train happy.
Well, the added cubic inches just brings peak torque down, right? And then as you lower the operating range. It makes the cam act a little smaller, and it makes everything a little happier, I guess, right?
Right. You know, so
the,
it's, you could turn this thing 8,500, right? You could. You could turn the bottom end 8,500. I have zero issue doing that with the Pro LS crank rod and pistons are rated for that. The problem is that your valve train, hydraulic roller
hydraulics,
stuff,
yeah, things start getting out of control when you start buzzing it up there.
they
so,
do. You know, so say 74, 7,500 is really common with an inexpensive spring pack. After 7,500, though, you know, things start getting more exotic, higher spring pressures. And when you put cubic inches under that, you can keep that valve train happy longer, so it's going to make some more power there than it would have. The other thing is that we can run huger turbos now compared to what we were going to have to run before to get them to spool. So, you know, 50 cubes, I'll tell you, we only had to make 1,000 at the wheels, which is 1,200 at the crank. If you want to see the dyno curve at some point, it made 1,202 horsepower at 27 pounds with those VS Racing 67, 62s. Everything in that thing was sized. The injector was sized for that. The turbo was sized for that. We could have added some 76s to this thing.
Yeah.
Really,
We've got all kinds of turbo offerings now that we didn't have back then. That
right.
Can,
but
we need to find some time to get that done and
we've got a perfectly good
blow something up or rotate the earth, right?
So the other fun thing is that we get to blow things up.
I don't like to blow stuff up.
I love to blow things up, as long as I'm not the guy running the mop. But I've blown so many things up. I'm very good with a mop by this stage of my life. You know, the other thing is again, getting back to the turbo kit. I keep circling around on things, but getting back to the 5th gen, the other really cool thing is just put a supercharger on it. You know, you just don't want to have any fuss, no muss. Vortex supercharger kit on that dude. You know, Pro Charger. They got some nice stuff.
Whipple.
There's some other,
yeah.
you know, and it depends on the type of power you want too.
Right.
So if you just want to stomp your foot under it and blow the tires off the things, you know, that Whipple or the Eaton, you know, base type of deal from Edelbrock or Magnuson, they'll blow the tires off, and that's fun until you're trying to hook it up.
Yeah.
So for that, you know, a lot of my people that I work with, they prefer the power curve of a Sentry, and it's easier to control, still makes tons of power. Those kits aren't light. They put a lot of weight on the nose of your car, and that's already a heavier car to begin with. And if you like to go around corners, that is another example of, you know, using a Sentry versus a Maggie is, you know, any weight that you take off the front end is just going to make the thing turn in and handle a little bit better. So if you're into handling and going around corners, that's another consideration. Plus you're saving maybe 60 pounds a kit.
Oh, probably. Yeah.
Right. So yeah, if I were trying to go 10s at a drag and drive, you know, and I wanted to just bolt things together, no fuss, no muss, put a Vortec on top of it.
Or Pro Trudge or one of them. Yeah.
Right, right. So Dave Shull dropped in. Howdy, we're there. And he says, happy lobes. They are happy lobes. So everybody's about their Spintrons.
Yeah, there is more power to probably be found in more aggressive lobes, but that's maybe not what every customer needs.
Right.
We've got to
the
market to the masses.
Well, yeah, masses, yes, but also the road racers, right? Drag race cams got a pretty bad reputation because they make power strong but not long, as Judd Massengill would have said, strong but not long. So these are parts that we will confidently send you out there to go run in a road race like TA2, TA3 Trans Am racing. As a for instance, these lobes are meant to be easy on your valve train, and the byproduct of that is RPM. A very, very stout cam, you know, saying in terms of an aggressive cam lobe, you might pick up 5 or 6 horsepower, but it signs off quick. With a cam lobe like ours, you know, you might sacrifice that 5 or 6 horsepower, but you're making it another 700 or 800 RPM longer. So it's that power under the curve that really, you know, accelerates your car. So when it comes to cam lobes, that's something that we think about heavily. And we could talk a long time about that one. Here we go. So Brian Walters, can't spell my name right, yet can pull hot rod together theoretically. Brian, that's awesome. You're just like me, man. That's awesome. It's good to hear from you. Mike Scano. All right, so this dude is a very, very cool dude. Mike, thanks for dropping in today. This is a very accomplished engine builder that makes really awesome tools, and he helps Summit brand out with stuff as well. We love engine building tools here, and Michael has given us some really great patented stuff that we've introduced here this year in the terms of our push rod link checkers. Do you want to explain how those work a little bit?
It's a pretty simple tool that you just drop in. It's spring loaded. You set the cam on the lobe of the, or set the lifter on the heel of the cam, set the tool in, bolt the rocker down, extend it. It's got a little, a 7/64
Grub screw in there. Yeah.
Set screw or whatever. You set the set screw, pull it out and measure it, and
Yeah.
you can add your preload to that, and you're done.
So I want to talk about this because, all right, we've been putting cams in LSs for 20 years, and they don't have an adjustable valve train. They're like a Windsor in that way. So we're taking even the good tools are a tight fit, and the comp cams is one of my favorite push rod link checkers in there. It kind of screws out, and it's got some numbers on it, but they're hard to read. And I could also tell you that it wobbles a little bit, and when you're trying to hit your number down to the thousandths, you just know it's not quite right. So the cool thing with this tool is, again, push rod in. It's in effect a snap gauge, if ever anyone's seen what a snap gauge looks
Right,
like.
yeah.
But it just goes in there, rocker down, tighten the thing down, pop the rocker off, measure this thing. It is exact down to the thousandths of what you needed in that motor. So that's a pretty awesome tool for the burgeoning engine builders out there. And we've got Kurt Ryan in here with lobster rolls. I don't know what that is. Richard Hunter,
Got it.
what size springs would you run on a basically stock 5.3 stage
missed-
2
you
cam,
missed that
906 heads and 70 millimeter turbo? This is fun. We want to get into dual versus beehive and what we've discovered over the last few years.
What size spring should I run on a
Stage 2 cam, 5.3
basically
turbo.
stock 5.3 or stage 2 cam, 706 heads, and a 70 millimeter turbo? I would think a dual spring on a turbo. I mean, you could put a 600 lift beehive. I kind of like the extra rate in a dual spring myself.
All right.
I feel that keeps it
So
more secure.
he and I are old school, where we just thought you had to have a dual spring.
I like a dual spring.
Dual,
Yeah.
just for the redundancy, all right? And the problem is that when you have a dual, you've got not just one spring, you got two springs, and that's weight. And the worst thing is that retainer that could have been, what, an inch in diameter?
It could be 7 grams is now 11.
Right. So the retainer weight is now huge, and so you've added another spring and a huge amount of retainer diameter to that thing.
That's why they have titanium.
Yeah, but I have converted myself to a beehive kind of guy, and the reason why is we've got these 600 beehives that it's the pack spring.
They're very good.
They don't
excellent
break.
material. we really don't see failures out of
Right.
them.
So again, this
we
is
sell thousands a year, and we don't get failures.
we just don't, right?
Yeah,
It's
so.
one of these things that when you have access to the data, you're like, and believe me, I'm over 50 years old. Small block guy. We needed our dual springs and all that stuff, but once you have this stuff and you see the failure rate is nil, it starts making a lot more sense. Once you get rid of redundancy as an excuse for running the duals, they start making less and less sense. So yeah, we've got the 630 lift duals as well, which I like those personally even over the 600 lift. That is a 174,005.
Right.
And that
It's got
one,
more rate in it, a little stiffer.
All right.
A little better back.
story time with Brian. When we did the Pro LS cams originally, we had 600 lift on a lot of them. We had 550 lift on a lot of the truck cams because that's our LS6 spring that you can buy for $76 or whatever it is these days. But then the 625 lift cams is really the maximum you could use with a factory rocker before the edge of the rocker scroll starts coming off the end of the stem.
Start to scrub.
They start to
dig.
scrub.
Yeah.
Yeah, so we set the biggest cams at 625 lift, and we were like, okay, that 600 Beehive isn't going to do. We're going to go ahead and put duals as our recommendation. The 2500, the TFS pack, 2500 286P for polished springs. We've sold thousands and thousands of those. Great spring. And that's what we ran with all that 625 stuff. So lo and behold, we introduced the 630 lift spring, and we've been using it now for years and now have good data that we feel confidently that we can just go ahead and put our 630 lift on the 625 springs. And again, it happily turns RPM. We had JP out there with the 600 lift Beehives turning 70s.
That's an anomaly.
So yeah, this is one of our friends that bolted our 92 millimeter T4 on it. Awesome turbo, by the way. Stock bottom end, and this guy's a lunatic. But he's got our stage 4 twin turbo cam in it, which we allow a little bit more overlap with the twin turbo T6 cams. And this engine doesn't want to turn off. And it's like, yeah, he's letting out of the pedal, and JP does not let off the gas pedal. But the engine was very happy turning RPM because we got great lobes, great springs, lightweight rockers, and it was good. So here's we good. So Richard, yeah, 706s.
We skipped a person.
Oh, we did. Hey, Brian and Mike, thanks for doing this. I just installed the 8709 R1 cam in my 5.3. What kind of bottom end would be bulletproof since I have all the power I could want? 8709 is a treat. So when we were talking about stage 4, the 8709, we designed that thing with the intake opening as early as it can be without kissing the piston, and the exhaust valve as late as it could be without kissing the piston. So that is the biggest cam that we sell that you don't have to worry about fly cutting a piston. Makes a lot of power, a lot of overlap. It's got 14 plus degrees of overlap in it. That one is awesome, and it likes to turn RPM. And you, sir, putting that thing in a 5.3, I'm not going to say you're a brave man, because you're just going to have to know that this thing is going to want to turn 8,000 RPM. It's just going to want to turn
big,
that.
yeah.
It's just.
So he's asking what kind of bottom end would be bulletproof? I mean,
well,
if you're NA, I would think a forged piston and a decent rod is
yeah,
all you need.
that's
and
really
a good,
all you
really good
need.
oiling system. So
yeah.
yeah.
So with that, here's the thing about that. That Gen 4 rod, because of that stroke in that engine, that Gen 4 rod would actually live for a good amount of time. I actually trust the rods to 7,500 for a little while, but you used the word bulletproof. And Mike and I are into that as well. So if it were mine, what I would probably do is run our 6 1/8 inch rod with our 5.3 piston. Now, the reason why I'd run that versus the 6098 945 version is it's a little bit lighter, the pin's lighter, so that's a good thing. Neither one really fails at all. But the nice thing about the Pro LS 5.3 piston is we give you a little tiny dome, little bump on top of that thing that's about 80 thousandths tall to help you recover compression, because a flat top in a 5.3 is pretty lackluster in terms of compression.
If it's a stock 7cc dish, that's even
Terrible, or
worse. Yeah.
Worser.
Yeah.
So we do have a great 5.3 piston with a little bit of a dome bump on it. Dome bump. Where did
Give it a little more wind and yeah.
So like cubic inches, compression is your friend. You're already paying for 92, 93 octane or 91. And if you're already paying for it, why not get the benefit from another half point of compression? They were very, very, I'm not going to use the word stingy from the factory.
Conservative.
They were conservative because they knew that people would be out there, towing something with their 5.3 and their, 1500 Chevy truck. So they were conservative with your compression, knowing that you weren't going to be running good octane and stuff. But, put some pop in it, like 11.0. I would not be worried about running 11.0 compression if I could. Not maybe if I'm towing, I'd drop
Dynamic compression with that cam is going to be not way down anyway.
Right,
so,
exactly.
yeah.
So yeah, I'd run 11.0 with that thing all day long if I could. Now we don't have a dome that big yet. Depends on when you are going to be building said engine, but you are going to start seeing some higher compression offerings from Summit Pro LS pistons here after a point.
He's got an L33, so that's got a flat top in it.
That's a
so,
nice,
yeah.
I love that engine. That is a specialer engine. So Toyo brings in aesthetics. Richard Hunter confirms 706 head. And Menfriend DeLorean, TrickFlow Double Platinum 660 LS dual springs and retainer kit. Great stuff. Yes, it is. So yeah, it's, again, rev it to the moon. These parts are built to hang. We should cover some of the questions people sent in.
Sure.
It wasn't exactly a little contest, but questions are good. If you've got a question, don't be afraid to ask it. I don't care if you've only been doing this 2 weeks. There's somebody else that has a question, and they're just afraid to ask. So first question was, on Project 1000, did you balance the rotating assembly first?
We did. We had to send the block out to have it bored, and we just had our local shop bore the block 30 over, and our block was actually a GM part that was returned in our returns area, and we snagged that for a deal, and it had a little surface rust in the cylinder walls that got wet on a shipping dock or something like that.
Yeah.
So we had to take it 30 over.
Gave it a second life?
Yep, and then threw a crank and rods in it, and while we were there, we just had them spin the assembly. We're working on offering those rotating assemblies balanced, pre-balanced, and we hope to get that done this year for our customers. So they don't have to balance. It already comes in a box.
I mean, we love machinists, but at the same time, there's machine shop jail, right? So it's, you don't want something, you order it, and then it takes 2 or 3 months to get something balanced. It can, right? Some people are great, it only takes you a couple weeks or a week, but it's just kind of hit and miss, right? So we're going to try to save you that stuff. We did introduce in 2023 the Forge Pro lineup of cranks and rods and pistons. So what's cool?
That's for conventional legacy V8
legacy
stuff.
motors.
Yeah,
So
yeah.
old school, small block, big block, Chevy, Ford, Chrysler, Olds, Pontiac. I think maybe even some Buick stuff.
I don't know if we did Buick. Yeah.
Not yet.
No.
We will. So
You need to get busy on that.
I need to get busy on that instead of blabbing here about twin turbo 408s. But getting back to that, what is Forge Pro? What is it? So we saw a lot of piston offerings. There are some big legacy piston builders out there that when they're not selling thousands of something, they take it off the shelf. And with that goes a good part that has lived forever. But honestly, they were saddled with some really poor rings, 5/64 dinosaur
Well, you got
stuff.
60s technology in that stuff.
Right.
The
I mean, they
old,
were
big, heavy
designed-
wrist pins and 5/64 rings and, heavy, horrible dome designs and valve
Right.
pocket arrangements and all that.
So yeah, made in America. That's a big thing with Mike and I. Anytime we can do made in America, we try. There are some parts that just can't be and be priced reasonably, but pistons are still one that we can get done here in the States. We gave those things the exact same rings that we run on our Pro LS pistons. It's a 1.3 millimeter. It'll go for a couple 100,000 miles, no issues. All modern engines are built around that type of a ring anyway. It gets rid of a lot of friction and
If you're
bore
building
wear.
a traditional small block or big block, why not have that lower ring drag and the ring sealing? It's free horsepower.
Right.
So.
Exactly, and bore wear, right?
Right.
These engines, oftentimes they didn't wear pistons, they would wear bores, And you look at something that still has crosshatch, well, buddy, that thing might have 4 thousandths worth of wear to it, and
Get the old ridge reamer out.
right, nasty stuff. So we used a modern forging with those. We were very careful with the skirt profiles on them, so the pistons aren't going to rock, they're not going to make a lot of noise or anything like that. So for a forged piston, they're going to be very quiet, lower friction, and I gave you that extra half point of compression there, so take advantage of it. Spend the extra dollar on higher octane fuel. You're only driving this thing back and forth to the fairgrounds anyway in many cases. Buck up, fella. It's a lot of power there. Did you use a bolt stretch gauge for the ARP hardware?
Yes, we did.
I love that tool.
It's certainly a nice tool. We also used the torque wrench and verified bolt stretch. We spent a little time experimenting on that, actually. So
I could tell the story on this one a little bit. So there's some people that will not sell a connecting rod by
With a torque number on it.
with a torque number, right? And that is all well and fine, except for a lot of people just don't have that. The torque angle gauges that are out there, the ones that just kind of bolt there and it's got some kind of alligator clip, throw it away. So what we did with ours, we've got a, and this is asked, there's an AC Delco torque wrench. If you type the words torque wrench into the search bar on the Summit website, there is going to be an AC Delco torque wrench that pops up. And this thing is a gift from the gods. When we first started doing this video, that thing was pretty low in popularity,
Right.
and we turned it into the #1 selling torque wrench at Summit, and for good reason.
It'll last you the rest of your life, number one. But
It's like Excalibur.
it's tool truck quality,
Right.
At Summit price. So,
Exactly.
yeah.
So the cool thing about this wrench is not only is it a digital torque wrench with haptic, meaning it vibrates, as you get really close, it's like, bop, 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 and it buzzes and beeps and tells you you've arrived at the number. Now that's all cool, right? What's cooler is it tells you the peak foot-pound number that it achieved. And if you're doing torque angle, that which we recommend, when we're designing and we're honing connecting rods, we're not torquing that thing down to 72 foot-pounds or whatever the number is. We are going to seat it at 30 foot-pounds, and then we're turning that thing 60 degrees or 80 or whatever the number is, and that is round. And that is what we recommend, is that you use this torque angle to arrive at the proper stretch to make sure that the bores and the pistons are round. Only problem is a lot of people don't have the torque angle wrench. So being the nice guys that we are, we did a big torque study and we found out that that's 82 foot-pounds of torque. The bolts are very repeatable. They are ARP 2000s. The machining quality is awesome. And it wasn't 80 foot-pounds. It wasn't 85. It was 82. So hopefully your 82 is the same as my 82.
With lube?
With lube. And yeah, so 82 foot-pounds was the number. We've got Proless rods have a couple different bolt lengths, a 1/400 and a 1/600. They've got different stretch factors for each one, so they've got a different foot-pound and torque angle number. But yeah, when you use a nice tool, buddy, I'm not trying to sell you stuff you don't need, but just buy it. I mean,
Gotta have it.
it's awesome
Yep.
stuff. I mean, had I invested in some of this stuff when I was 20, 25 years old, I mean, it would
They
have been.
didn't have that when you were 25 years
Well,
old.
it's true, they didn't have it. I had the beams type of stuff. All right, so here's a fella, he says, I want to build a 6.0 LQ4 with these products work in mind. Absolutely.
Yes, sir.
So with the 6.0 LQ4, for those that don't know, there was the LQ9 and LQ4, and really the only big difference between them was the LQ9s had a flat top, the LQ4s had a little bit of a dish, which is a little bit more friendly for compression anyway, for boost. You could use that piston for a bit, and the only problem is gapping rings, right? You could gap the rings and they'll live for a little while, but they're probably worn out to begin with if it's an LQ4, because that's a 20-year-old engine at this point. So yeah, I would put a new set of Proless rods and pistons in it, and balance the crank and some LS9 head gaskets on it. And
Might have to go oversized, depending on your bore.
I mean, we do make standard bore. We make 5,000ths over, and then we go straight to 30. Might have some other offerings at some point in the future, but we go straight to 30. If you're going to put the boring bar in it, just make sure it's going to clean up in 30.
Yep.
Also deshreds the valve.
A little bit.
Yep, a little bit. So the bigger bore helps there. Did you use the Summit brand LS3 crankshaft and rods, or just the crank and rods sold from Summit? Yeah.
We used to forge crank.
Yep, our forged crank. Again, if you're going to spend money on a crank, which we do, you can go standard stroke, or you could
We
go
didn't
with
have
a
a crank.
flat
All we had
stroke.
was a block.
Right, we started off with a bare
Yeah,
block. So we're going to put a crank in this thing, and then we had the choice of running standard stroke or stroker. And again, you don't need the stroke with turbos. It's almost maybe not a good thing to run a big cubic inch with boost. I'll get into that after a bit, but the reason why is, what are you going to do with 1,100 foot-pounds at 3,500 RPM?
Right.
Right, we're going to get into that after a bit. What crank bearings did you use, and what size rod bearings did you use?
We used the Clevite 77 or the
Ages.
what's that? The H bearing. We used the Clevite H bearing in there, yeah. And I believe we had to do the X bearings to gain a little extra clearance there. So it was a little snug when we first mocked it up.
So we love a 10296 Melling oil pump. I use that stuff and everything. I think there's a commercial.
Right, it's not Frank's.
Right. So, exactly. Can't say that word on TV. At least we can't. But anyway, so at H bearing, we put this thing together what we thought was fairly tight in terms of clearance, and we had triple-digit oil pressure.
Right.
The first time out. And so after we saw that, we're like, you know what? We're just going to put X's in this thing. And
We had to back off on the pump too.
we did.
We did
Yeah,
a
we started off with
10295.
the 10355 pump, and the 10355 is designed for AFM. And if you're running really loose clearances, the 10355 might be the way to go. But what we found was we backed out on the pump and ran X's. X, if I haven't mentioned it, X is 1,000ths, right?
One extra.
One extra. And so instead of that typical 2,000ths or 1/8 being 0.0018, that's 1,000ths and 8/10ths for machinist speak, the X's would add 1,000ths worth of clearance to that, which is pretty standard for a performance engine. Again, we weren't lacking for oil pressure, and things tweak. I mean, as many foot-pounds of torque as we had going through that, people got to remember 1,100 foot-pounds of torque on this thing. That's trying to tear your motor mounts off the side of the block. That's why you run motor plates on some of these things, right? That's going through your motor mounts, and that is putting a lot of tweaking on your block. And those clearances that you start off with static, when you're building something on an engine
It's trying to
stand.
bend the crankshaft in half every time the piston fires, right?
Right, right. Exactly. We like torque. Here's another question. Absolutely. I'd love to know what the build cost is. I'm thinking of for my 2001 Vet, I do some autocross. So this was not an inexpensive engine because we built everything brand new. But the rotating assemblies are 2,600.
Yeah, they're not bad.
Something like that. So we also don't go chintzy on the parts we throw into that. That's a Clevite H bearing. It's not some no-name bearing. That is a great made in America ring pack that we use with those things. You know, we're not out there trying to make the prices of our...
I would say that motor was probably, with heads and gaskets, fasteners, valve train, pushing close to $12,000 or $15,000.
Right.
Yeah.
And the turbo kit, now that's where a lot of
That was a lot of
expense
cost
gets
in the turbo kit.
Right. Now that's where things get...
If you're a
they can be really
fabricator, you can probably save a lot of money on that stuff. you know.
thousands and
Yeah.
thousands of bucks. But anyway, like I said, you know, we're Summit Racing, right? If you've got good functioning coils, use good functioning coils. You don't have to buy everything brand new. Reuse as much as you
Right.
can. But, you know, you want to tell them what we found with coils?
Well, on the coils, we had it was a stock GM coil, I believe, right?
Yeah.
Or it might have been at one of our Summit aftermarket coils. But once we started to reach extreme cylinder pressures, we started having misfires and breaking up and all that. We actually had to take the spark plug gap down to
14.
I was going to say 15, under 20 thousandths to keep it firing. One cool thing that I'd like to go back to the dyno and try is we now have our own Summit
IGN 1X.
IGM 1X type smart coils, and I'd love to try those out on that engine and see how much gap we could get away with that guy, and do a little welding with those. So
It was pretty cool. So the power curve on the engine on the dyno, it was going up and up and up like that, and then it took a dip, and then it would come up like a little curlicue at the very end of that thing. And if you looked at the torque, it was flatlining. That spark was only going to jump that amount of gap with that amount of cylinder pressure. And so as cylinder pressure came down, it allowed the spark to come back, and it was allowed to make more power at the very end as cylinder pressure decreased. And the fix for that was just tightening up plug gap, which you never know that stuff until you're on the dyno That stuff
Cool
is
lessons to learn, right?
cool. I mean,
Yeah.
to try to do this at the track,
Oh my gosh. Figure that out and making a pass at a time.
it could have been my torque converter.
Right,
It could have
yeah.
been this. It could have been. Gosh, no. There are. We have a good friend here. We've got a couple local chassis dyno shops that do great work. Backstreet Performance and Big Three. Big Three more drag race. Backstreet is a little bit more road course oriented. Both very, very good. But we uncover so much stuff on the dyno over there. It's ridiculous. A lot of it is fuel related. These fuel pumps and everything we use, I mean, they're great pumps, but you're just not going to know what's going on until you have a wideband O2 stuffed up the pipe on this thing to know that everything is working as it should. And that's stuff you're not going to find out, at the track easy. And what oil did we use in that engine, Mike?
We used our Summit ZDDP 10W40.
Right. So we got into oil a couple of years back, and there's, as most of you probably know, we don't make oil. But what we do is we spend a lot of money to buy big quantities of really awesome stuff, and we don't have to take shortcuts. We've got the resources to do this right, so we were very, very confident in Summit Oil. Very proud of that stuff. It's great. We priced it like Mike and I can afford to put in our own cars. If anybody ever wonders about our pricing strategy, that's it. We have to be able to afford it for our own
It's got to
stuff.
be attainable by a working class dog, right?
Right. So anyway, don't tell my boss that. What type of transmission would be required for this build? And I know it's going to be built. And your thoughts on that?
I mean, you need I would think a Turbo 400 with all the best 300M 4340 pieces or whatever
Yeah,
that you can get.
480 would do it
480 might hang in there as well.
with the right triple disc converter.
Right. With that much torque, you don't even need the overdrive. You just gear the car with a
Right.
273 and
Just run it.
and put a 400 in it and let it eat.
So the problem is like a 4L80 built to take this stuff gets really, really expensive.
Right.
And it's nice to have that extra gear and that lockup converter, but for most of us, the Turbo 400 would be a good choice. And again,
Pretty tough to beat for the cost and the technology that's there. It's simple.
Right.
So, yeah.
So and here's the other question, like why a stroker? And see, Mike wrote, why not? So
we had to buy a crank anyway. So.
we had to buy a crank anyway. So yeah, we kind of got into it a little bit earlier. It's like, 408 cubic inches, it's another 50 cubic inches, right? It just, it's not a bad thing to have more power. Again, we're able to size a turbo ridiculously large with that. And again, you're lowering, your RPM range. So if you had a 5.3 or a 6.0 wanting to turn 8,000 and your cam and springs are signing off, you're never going to see the benefits of that. Versus we put a bigger stroke under that, use that air earlier, and those Valtrain parts go back to Happy Land, and you see the power gains there. Not from the cubic inches necessarily, but just because the Valtrain is more
torque
stable.
earlier, yeah.
Yep. Here's the question again, was what manifolds and piping are you using? Is it all custom or is that a kit that I can purchase from you guys? And the answer to that was no, we don't have a lot of turbo kits.
We do now have a dual turbo manifold setup that we would be pretty awesome to retry on that engine. So,
Right.
Yeah.
And we will.
Yeah.
We got to go back to the dyno. So something that's happened since we did this engine is, this was Mike's baby. We came out with two different cast stainless manifolds. One of them is a single turbo manifold, and the cool and unique thing about that one is it's split plenum.
Correct.
Most of the turbos that we're running on these engines are divided.
Twin scroll.
Twins,
Yeah.
yeah. Well, in divided. So it's with that, we've got the passenger side hitting one side of this. We got the driver side, passenger side, each hitting half the turbo, and that necessitates that we've got a gate on either side. The gates are inexpensive. Our Summit gates are $100.
$100 a piece.
Right. So now that 44, 45 millimeter gate is controlling half the volume that it used to have before. So we've got very, very fine control, all designed in CAD modeling, so it actually fits with the the AC compressor and all that with a truck accessory drive. We've got a pretty cool video there that we did where we hung the turbo, hung our, I think it was a 3-inch downpipe off the thing, kind of showing, how it cleared the coil packs and the wires and all that fun stuff. So there's some information out there if you want to know about that. The other cool thing is we got twin manifolds.
The twin manifold that's a high mount that
Yeah.
it's got a wastegate on each side as well.
Yeah. So the high mounts, I have a C5 Z06, and I've sacrificed the hood to the gods. I'm going to be running twin turbos out the top of this thing now. But it's awesome. We pull the turbo up away from the brake booster and all that stuff. So I've got a 7-inch booster over there, and I clear actually by a mile now. When finding the right pushrod length, why did you add 70 thousandths to it, and how do you come up with that number?
You did that, I don't recall.
Oh, I did that. All right, so we've got LS7 Delphi lifters, and people talk about lifters, LS7 lifters and that. So the original LS7 lifters have not been made for a long, long time. Delphi makes all the really, really good ones. And the problem is Delphi's, as of late, have got a reputation for being not great. And the problem is there's a lot of unscrupulous fellows that sell things over on Amazon that call them Delphi lifters, and they are not. They are junk. And people put them in their engines and they don't operate well, and then they're like, but I had Delphi LS7s in it. No, you didn't. And we know that because we know how much they cost, and we know where we sell them at, and they are value priced. You can trust a Brian Tooley LS7 lifter or a Summit. We know what they cost, we know where they need to be priced, and if you're buying something significantly less than we're selling it for, it's probably not legit.
Not the real thing, right?
Right, and the problem, lifters are the most finely machined part in the entire engine. Tenths of a thousandths.
Yeah, that plunger clearance is really tight.
It's critical, right? And even when it's right, it's hard to make them right. But again, Mike and I have access to the data to see failure rates and warranty rates on all this stuff, and I have zero issue running a Summit Delphi lifter and all these things. So going back to a Delphi lifter, what makes the LS7 kind of cool? A lot of lifters might have a couple 100 thousandths worth of plunger travel. A genuine Delphi LS7 is 166 thousandths. I know that because I measured it. And we put that plunger roughly halfway in the middle of that. You could run anywhere from 70 to 100 worth of preload on that. The benefit to doing that is the less oil you have in that lifter, the less it aerates. And when the less it aerates, the more net lift you have with it at high RPM. So you have to be a little careful with that though, how much preload you put into it. But yeah, that 70 number, 50 to 70 is what we recommend for pretty much anybody that is, roughly one turn of the rocker stud there, rocker bolt. But you could go a little bit more with that if you really want to get good. And we talked about the manifolds, and we talked about the AC brackets. How long do you expect this combination to last?
Forever.
Yeah. So the truth is Mike and I
we really don't know that. I mean, it'll run till it doesn't, right?
Well, so the weird thing is I was talking with a fellow last night who had the same question. And again, we've had these parts on the market a long time. I've been designing parts professionally, pistons in particular, since 1999. And I know that there are engines out there with well over 100,000 miles, right? And the Peralez parts have been out since 2018, and in a lot of applications, I'd be kind of hard to gauge, like, how many miles could a guy put on this thing? I had a guy yesterday in a conversation, he goes, I have got a Peralez rotating assembly in my 6.2, and I've got over 200,000 miles with my boosted 6.2. And I'm like, dude, you just won a prize for that. So yeah, I don't expect these parts to break. It's kind of ridiculous.
They're well
to
built
say that.
and well engineered, so the quality's good.
Yeah.
It should last a long, long time.
Right, exactly. So. I mean, and people say tuning's everything. Well, good parts like a forged piston are built to withstand hiccups in your tuning process. Everybody thinks they're a good tuner until they melt a hole in something, or their fuel pump fails, or something. But these parts are meant to take a beating. How much force is needed to crank the assembly? He just installed his Summit rods and pistons, and it takes 65 foot-pounds to spin with no heads on. You, sir, have a problem.
Sounds like something's off. Line hone or something. I don't know. That's really high.
Yeah.
We spun that at what, 25 foot-pounds, 22 foot-pounds. It was fairly light for a street motor.
Yeah, and so we call this breakaway torque because a lot of us don't have fish scales or any of that business. But if you take your short block built with the rings, with the pistons, with the crank, and it really depends on what oil you've got on the mains as well when you're putting this thing together. If you assemble it with a no oil or very, very light oil, not break-in lube, 13 would be kind of a normal number for a street engine, meaning that you'd be like turn, and boom, that rotating assembly would start to spin, and you look back at that peak and hold number on your torque wrench, and that's about 13 foot-pounds of torque with a standard set of standard tension rings in the thing. There are dwell points on pistons at TDC where they're up and down on the bore, and that applies leverage to the thing. So you have to do that test a few times, but I think, on our engine, it was about 22, 23 foot-pounds of torque, and that was with real break-in lube
Thick,
on the mains.
gooey,
Thick, gooey, sticky stuff. Also, we do like lower tension rings, but not too low with boost. And frankly, most of our engines that we build, Pro LS pistons for are going to see boost or nitrous, and oil and does bad things that causes detonation. So we run a standard tension oil with our ring packs. Not to say that that's old school 3/16 or 5/64 type stuff in terms of tension. It has something to do with unit loading. So it is lower tension, but it's still considered standard for a modern vehicle. So we're running standard tension rings in that. And if you've got 65, something is locked up. And we furnish these rotating assemblies with standard bearings. And that's cool if your block is truly what we call on the split. There's the housing bores in these blocks, the main bores. They've got a range. It's either a little big, a little small. When you torque the bolts, those bores get small, and there goes your bearing clearance, and things get tight. And you're never going to know that until you put a dial bore gauge on something with a transfer mic. A transfer mic, basically what you're doing is if you want to imagine, here's your main journal on your crank, you're setting your micrometer off of that so you have true zero. You are putting that thing in a mic stand, or in my case, a nice vise. And we're putting our dial bore gauge indicator in that thing, and we're getting our net clearance. So I'd like to see something more like, say, 2/1000 and 8/10 worth of net clearance on that thing. And that thing should spin just like, it shouldn't have any high spots or sticky spots or anything.
You should be able to spin it, and it should keep going once you stop. Once you take your hands off of it, it should spin a half, 3/4 of a turn, nice and smooth.
If it spins,
as you rotate
it wins.
If you're spinning it and it stops when you let go of it, it's not. You got an issue. High spot in a bearing, or a part that's out of alignment, or a cap that's crooked or something.
You got to know what
backwards
it is.
cap.
Right.
Yeah.
And again, we trust the Pro LS parts. They are awesome, but
it's probably not the part.
It's not going to be the part, I can tell you that. But there's something, right? And it's
Dirt.
got to be found. And so, again, getting back to these engine building tools, back in 2018, we did not have a dial bore gauge that went down to 1/10 of a thousandth. And the best one was only good to 1/2 of a thousandth, and that's not good enough for engine building. So we, again, set the price on kill on a really killer dial bore gauge.
It goes to 1/10. Yep, we've got
It goes
those.
down to 1/10 of a thousandth, so that's 0.0001. Sounds like a really small number, but in engine building world, that's standard. Okay, here's some fun ones. I thought you were supposed to put the bearings in dry. I never heard of that before.
That was on a cam bearing video we did.
It was.
And I put a little assembly lube on there just to keep it from drawing a burr and scoring the back of the bearing real bad. So
So putting something in dry, you could do it, but anybody that would ever tell you like, oh, you put oil behind a bearing and somehow it's going to magically slip and fall out or something, that would be ridiculous. Put oil on the backs of your bearings. It makes them go in nice and tidy. They go in without cocking or doing anything bad
sometimes
or getting
they're so
burrs.
tight anyways.
They're
just-
tight,
Yeah.
right? Even with our really super awesome $80 cam bearing knocker, it takes some work to get that done. So put a little lube on it. Can the cam bearings be pushed in or out of the way, like there's no tape or anything in the cam board to do this, if you overshoot from installing them? Yes, sir. Yeah, they basically will pop out the opposite side. You pick it out with your fingers and start all over again. So
Hard to do once an engine's assembled.
it's true. Yeah. Do your cam bearings before you put in your rotating assembly. I guess if you're trying to put cam bearings, all right, so this is a big deal, my friend Matt Happel. Never look at the cam bearings. LS cam bearings, again, sorry to my
Some of
buddies
these
over at GM.
175,000 mile
They
engines
are
are shot.
nasty. So the problem is that, an old school small block Chevy, you never saw cam bearings come out of an engine looking as shot as an LS cam bearing does. But the engines run forever compared to a small block either. Like,
Right.
you used to get 100,000 miles and you ran a carburetor and washed down the cylinder, so you never saw cam bearings go. But all these LS engines run for 200 plus thousand miles. The cam bearings wear out. And then here's the problem, okay? You've got a cam bearing that's down to copper, and you're like, well, that's not good, but is it going to run? It might run. The other problem is then people go to stick their LS2 timing chain on it. We got a $22 timing chain. Again, never breaks. I don't want to tell you anything else because this wonderful little $22 part lasts forever. It's great. But it's got a little bit of wobble in it. I'm like, why is that? Well, it doesn't do it on a new block, but it somehow does it on this old engine. So we tested bearing clearances on one of these engines that was 200,000 mile engine. This thing looked awesome. The rod bearings, the main bearings, we did this with Coverman 66 Terry LSX, if you know him. And we took apart his engine and checked this stuff, and this engine was super well treated, probably fleet maintenance or something like that, but it looked awesome inside. But the cam bearings had 8,000 clearance to it. And if you think about that, that cam is now 4,000 closer to the crank. All right, and what that means is that you need to run that 5,000th line honed chain set. They have these things called line honed chain sets for any of the old
We
school
sell
guys.
the upper sprocket in 5 and 10 thousandths undersize.
That was my idea.
Oh, I know, it's pretty slick, actually. It works well.
Again, try not to rip you off if you don't need it, because who wants to have to pull a lower sprocket off the thing, right? But yeah, we came out with a 5 and 10 thousandths line honed sprocket. Same number of teeth count, it just increases the diameter slightly to accommodate for worn cam bearings and stuff, to bring that chain back into the proper tension range to get rid of all that slop. Again, brought to you by Summit Racing. Nobody else does that for you. We do that. What else? So can cam bearings be pushed in or, ooh, this is a fun one. So can cam bearings be pushed in or out either way? Okay, we talked about that one. Why is the tool so long? It seems to me that it's almost twice as long as it needs to be, and ought to work fine if it was shorter. From a manufacturing perspective, nobody's going to want to make something with more material than is needed unless there's a reason. So it must be intentional, but I'm just not sure. And what did we create?
We have a Band-Aid tool for that.
We have an awesome tool. So the problem with the tool is, it's not really a problem with the tool.
Me personally, I like the length of a tool. I like to go in from the front of the block and do the rear 2 cam bearings, or maybe the center, and then reverse and go in from the back of the block and do the front 2. It just centers the tool up a lot nicer when you've got the cone further away from the bearing you're putting it in.
Right.
And
So
that
when
usually
Mike
makes the
designed
cam
our cam
install.
bearing knocker, he took the width of his shoulders into account for the design of the tool here. So when he swung that thing, his arm was exactly 90 degrees. Now, getting serious for a second, part of the reason why is when you go to do the number one cam bearing on these engines, you don't have an alignment cone on it. If anybody's seen our cam bearing tool, it's registered on one side, so it carries the bearing. It can't flop out or go loose or anything like that, and it goes sweetly right into the cam bore. The problem is the very first cam bearing bore, you're out there, it's hanging out in the wind, and
If you're doing it in the car or with a transmission
Yes.
hooked to it. So.
We have got a fix for that. It's a really swell idea. It's a tool. We'll try to get you this tool in the comments or something like this, but it actually bolts to the front of the cam bearing or the cam retaining plate, and it extends out this tool. It looks, it's hard to explain what it looks like, but it extends out the front of the cam bore, in effect. There's a little circle in the one end of it, spaces it out about 16 inches, and that gives the locator cone on the cam bearing tool a place to go, so that first cam bearing.
Is that on the website yet?
That's my job. I should have been getting that thing up on the website. Come on, man.
It's brand new.
Brand new. Again, when you build engines, you have inspiration, right? That's another reason why we build a lot of stuff here at Summit Racing is like, you just see a problem and you're like, I can't be the only person having this problem. Just like Mike, when he's trying to put push rods in his LS motor for the first time, he's like, there's got to be a better way. And sure enough, there is. So we've got a really cool tool that, again, bolts to the front of the block, gives a register for the cone on the cam bearing knocker in there, so that number one cam bearing just goes choop, perfect, aligned,
It's
no
cheap.
problem. Inexpensive. That's our style. Will this tool work with the rotating assembly installed? It does.
It's hard.
It's hard, man. It's hard. Again, if you hadn't had that tool that we just devised to be able to do the number one bearing, it would have been pretty much impossible.
I don't know how you would see with the rotating assembly installed the oil hole, that you get in the oil hole centered and the oil hole in the bulkhead.
Yeah, so that's another thing. So we're using an Allen head wrench to basically kind of feel in there and make sure that the hole in the cam bearing aligns with the hole in the journal to make sure it's getting oil. And man, to try to do that with the rotating assembly in the way would not be fun. Okay, don't LS engines need thinner piston rings, which helps reduce friction and increase power? I know, I've seen it, I've tested and proven, and I thought I heard of that. And yeah, we talked about that.
That was one of the features that when GM built those engines, they
Yeah.
added the thinner ring that seemed to improve
Yeah.
a lot of that stuff.
It's so big. I mean, they've got gas mileage targets, right?
Right.
And, friction is heat, and it's reduced gas mileage, and it's wear. So, again, yeah, we run that 1.2, 3 mm ring on almost everything, all the Forge Pro pistons except for the big blocks.
Yeah.
And those, we went with the 15153. And for people that don't know 15153, that has the same basic thickness of a 16th ring, but from the face of it to the back of it, that's radial wall. It's reduced quite a bit, and that takes a ton of tension out of that ring. So a lot less wear, a lot less friction, and still get a long, long life out of the thing. All right, does the dot on the second piston ring face up or down? I know the dot on the oil ring faces down, but the second ring, never seen that. But the second ring also has a dot.
You need to follow your instructions on that because it might have a dot, it might have a bevel.
A lot of rings, and including a lot of ours, they don't even have a dot anymore. And that's because the ring can be put in either which way. It's actually designed to go either which way.
Okay.
And that's a little bit of a problem because it's like, if you're like him and me, we just grew up with, even if it didn't need a dot, it had a dot just to solve the problem.
Sometimes they got a bevel on the backside or something like that.
Right.
Yeah.
But yeah, so dots up. If you got a dot, put it up. What do I do if the oil ring stops the piston from going up and down on the bore? I don't want to file because it's close or something. All right, oil rings. Ring end gap on an oil ring isn't commonly checked. We usually open up that gap quite a bit so you never have to file an oil ring. Generally, like 11 thousandths or something would be pretty common on an oil ring wiper gap. And that one does not have to be really loose. And the reason why is your top ring is the one that sees almost all of the direct heat. Your second ring sees a little bit less heat, and the oil ring is bathed in, engine oil, which is, 270, 290 degrees at most.
It's going to cool it very
Right,
well.
it cools that ring so it never does get hot. So if you've got less than 10 thousandths worth of wiper gap, I guess you should open that up, but in general, you shouldn't find that. It's good to check it. It's hard to square it up because any kind of a feeler gauge you run in it is it's gonna be touchy to do that, but by and large, most people aren't going to have to file. Here's a fun one. From the Torque Angle video, where can I buy the wrench and where can I find the specs for my engine, S38B36? Thank you, great video. Again, I guess with that one, I'm just gonna go onto the Summit website, summitracing.com, and in the search bar, I'm going to type in TORQUE. If I could type wrench and hit my return button. AC Delco, part number ADT-ARM303-4A340. Holy cow. That is $209.99, and it's a 1/2 inch drive, and I'm going to give you a range. It goes anywhere from 12.5 foot-pounds to 250.7 foot-pounds. That is a lot.
It's a nice tool.
And it features a 720-degree angle finder. I cannot recommend this tool enough. I've seen wrenches out there that cost 3 times that aren't nearly as nice. So game on for that part. We love it. Doesn't matter if your chain has a master length and is as opposed to just a full riveted chain all around. Is that even an option? The only time you're going to find a timing chain with the master link on it is something from an overhead cam.
I think that's, overhead cam stuff. That's not normal V8 stuff.
Yeah. So yeah, all of ours are going to be riveted. Again, that LS2 timing chain, they thickened up the segments a little bit versus the old LS1. One thing that we do really tell you to do, and again, I'm not trying to sell you a $25 part just because you don't need it. Get one of those LS2 timing dampers that they use. The factory put it in there for a reason, because the chain whips. And when the chain whips, it goes and it does bad things. I have personally broken a Cloy's timing chain. It wasn't pretty. And the Gen 3 blocks, most of them did not have the damper in it. TrickFlow makes a really cool device. It just bolts right to the cam bearing retainer plate. It drops down vertically so you can put the LS2 damper in there, and it keeps the chain from having too much freedom that could cause whipping. Also, if you have an LS3, they went to a tensioner later on in life. I've seen those tensioners broken from the factory. A guy does a cam swap, pulls off the timing cover, and he's like, holy cow, my timing chain tensioner was broken. So go back to that LS2 style plastic damper. It's kind of pyramidal shaped. From the cam bearing clearance video, where do you take bearing readings for the bearings to get precise measurements? Okay, so that went back to the conversation a little bit about the transfer mic.
Right.
Yesterday, I was doing my actual job instead of doing videos, and we have a brand new dial bore gauge setting fixture for people. This thing is pretty awesome, and the transfer mics are pretty neat if you've got a pretty good mechanics feel for them. But we've got a pro grade dial bore gauge setting fixture now that has 36 gauge blocks, and it will measure anything from something that's 1/2 inch, say on the very, very low side of a very small dial bore gauge, all the way up through 6.5 inches, and it has NIST certified gauge blocks in it, so you can trust that thing at 68 degrees or whatever that SAE temperature is they're going to be perfect, so you can now set your dial bore gauge off of that. So again, That isn't for a lot of people.
Most guys in a home shop,
Transfer mic.
I mean, yeah, it's really hard to even get a dial bore gauge in a block to check that. But if you get your new cam bearings in and you put the cam in and it spins nice and freely, you're most of the time going to be okay.
Yeah, I mean, if it spins, it wins, right? But
Right. Worn
yeah.
cam bearings, you're going to need the more advanced tools.
a lot of put
better
cam bearings
mic
in,
and
and then all of a sudden they can't spin their cam. So that's why you need to spend the money on that good tool. Again,
Yep.
it's $80, but when you see the amount of really good steel you get for $80,
The expandable O-ring tool is very hard to get a set of LS cam bearings in
yeah.
without deforming it. It seems they get high spots and deform. And
He and I grew up on this thing. It's got a big rubber band around a collet that expands when you torque this thing down, and
They're very
it's,
common in small block and big block Chevy world, but they don't work on the LS stuff. So
So have you got new mandrels for our tool yet, Mike?
it's very close.
That's his job.
So
All right, so we're busting each other's chops here. Please, is there a way to file and measure a journal on the main with the engine in the car?
not that I know. You could plastic gauge it, get close maybe.
Ugh.
It's the only way I would know.
All right. What is your part number for the digital bore gauge? I'm glad you asked, sir. Let me get that right for you. I'm going to type in dial
It's SUM.
bore Summit Racing dial bore gauges.
Is it a 9041-1?
Hold, please. Damn, you're good. Sum dash 9,000, so 90041 dash 01.
Oh, -01. My bad.
You got it wrong,
Yeah.
right? All right, so that dude is $185.99. It comes in that, I'm not going to say it's a chintzy plastic case, but I've seen that red
Blow molded.
blow molded. It is not the fanciest. I tried to get pine or oak for you guys. They don't have that stuff available. So it is a dial bore gauge in a blow molded red case. Here's the thing about it. That tool, we had that tool originally with the half thousandths indicator, and Mike and I are using it. It's like, we don't want to build an engine with our own tool. So we sourced a really, really awesome indicator. And there's 10th indicators, and then there are 10th indicators. And this is the one with the emphasis on awesomeness. So it has really, really great repeatable action. It's a very high dollar indicator attached to a value tool. So
It's a very good quality tool. It's
it
a
works
lifetime
well.
piece. Yeah, I mean, if you're
you're never going to buy another one.
no, you really don't need to.
Yeah. So 185.99, and again, tenths of a thousandths accuracy, 0.0001, and it's got all the the arbor.
All the different sized mandrels.
Yeah, thank
Yeah.
you. Yep. Main blank there. So please elaborate on the rocker bolt rotation and lifter plunger. Again, that's mathematical, so the thread count per inch is really what determines your plunger travel. That one turn, pretty common, for people to use that number. Luckily, a
It's
lot of
an M8 by 125 thread, I believe. So, however many. So it's 1.25 millimeters per
so again.
1.25 threads per millimeter, right?
So the thing is just go ahead and buy the fancy dancy Mike Scano designed push rod length checker. Let me do this check. Push rod length checker.
I think that's about 55 thousandths if you convert it over.
So easy checker. This is kind of weird. So these are really new parts. The first one that actually pops up is the one for raised runner LS, which is actually a fairly uncommon deal with LS heads. $99.99. and fits a bunch of race runners' heads. Now, here's another one called a SUM-PLC LS7276. Again, $99.99. It's really designed to have a travel of 7.200 through 7.600. So that's everything outside of like a LS7.
Right.
Right. So that would be the awesome tool you use. The cool thing about that is that say you have some short travel lifters from Morel or Comp or us. Those things might have 33 thousandths worth of total travel in them, and you're trying to get that thing roughly halfway in between. It is twitchy trying to hit that number exactly. It's a pain in the butt. And anytime that you have two different lifts on your cam, like say a lot of our LS cams have 625 lift on the intake lobe or 605 on the exhaust, well, the base circle's shorter, so the lifter is actually farther down, on the high lift lobe than it is on the exhaust. So we've actually got two different push rods. My personal engine, my LS7, I've got 4 different push rods in the thing, one for each bank and one for the intake and the exhaust, because I've got 2 thousandths worth of variance on one side of the deck versus the other, but I'm trying to hit that number down to 19 thousandths. And without this awesome push rod length checking tool, that is a very hard thing to get right. So that is a tool, if you're going to be building LS engines, I'd highly recommend that. Would it make sense to measure lash and add the push rod length? Oh, I love this guy, to save time. Yep, I just answered my own question. On the push rod length checker video, is this set up for hydraulic lifters? Yes. We need to do an easy checker video.
Yeah, we probably do. Yeah.
Would you rather have me doing that or my real job?
I don't care.
Okay. Question for anyone. At 738, he's manually trying to turn the crank by hand, and there's some light resistance. I have that and just a tiny bit hesitating. We talked about that a little bit. Outside of a Pro Stock engine or a NASCAR engine, you're not really going to be able to turn the snout of a crank by hand when you've got rods and pistons on it and rings. So with that, we've talked about that breakaway torque value where it's not spinning, it finally starts to spin. You look at your handy dandy AC Delco peak number there, and it achieved 18 foot-pounds or 14. That would be how you know that you're right there in the zone, right, of where we would expect. If it's 23, if you got a big old big block with a rope seal in the back, that could be 30 foot-pounds of torque trying to get that thing horked over with 5/64 rings. So that's why we like a modern ring pack, even on those older engines.
Even 16/3
Yeah,
rings
still
have
terrible.
a lot of drag. Yeah.
But again, if you're assembling this thing and you put one rod and piston on this thing and it's 6, you put another one on, it's 8. You put another one on and it's 10, boom. And you put another one on and it's 20. It's like, whoa, something just happened. This is a way for you to gauge what's going on in terms of your rotating assembly to try to find, like, is this thing out of the norm? And if it is, I really need to go back in and find out why. And I might have to spend some more money on cool tools to do it. So, all right, I'm going to go get some more questions from our commenters. Nick Sticks. Love the live stream, Brian Nutter. Keep up the great work and pushing new options for enthusiasts and racers alike. And then Rosa. We have a hello from Rosa. Hi, Rosa.
A bot. Hey.
Is Rosa a bot? We
I
never
think
know.
so. I think
We like bots.
looked like a bot.
Looks like a bot. Pretty attractive for somebody tuning in to Brian and Mike's
That's right.
Summit live stream here. We never quite know these things. Am I allowed to say that on TV? I don't know. Anyway, we've had a great time here. Again, thank you for joining us here today and talking about Project 1000. We'll go ahead and try to throw in the comments part 2 of this video, and I think maybe we'll even try to talk the guys into doing a part 3. Part 2 is really Mike and I assembling the top end of Project 1000. We really do need to talk about what we did with it, though. Okay, we're not turning off the video yet. We're just going to keep going. I could talk about engines all day.
I guess you can, yeah.
Anyway, so the second half of part 2 video is where we really take the engine over to the dyno. We put the intake manifold on it, the injectors, the coil packs. We run the thing in on the dyno. We're checking plugs, making sure we got fire in every hole. We got good oil pressure. All of our turbo lines are great and run well and not leaking oil anywhere. So we did our first pulls on that thing. Do you want to just, we've not had a twin turbo engine on that particular dyno up until that engine was on the dyno. So you want to
Right.
talk about what those guys ran into over there?
Well, we started to really build some torque, and we ended up having overheating issues on the dyno water and we actually boiled the water in the brake, and we had to make they had to make some adjustments and learn that
Right.
how to handle that kind of power, and then actually we had to shorten up the run time because it was making so much heat.
So,
We went from like a 3,000 RPM sweep to like a 2,500 RPM sweep or something. Just
yeah.
to,
So,
to,
so we wanted to see like what kind of torque, like when these turbos were going to come on. So we used a VS Racing 6762, and I can tell you a little bit about those things. I'm VS Racing Turbo. I think I've even got a part number in here somewhere. So on our website, if you want to learn how to navigate stuff, so I just typed in VS Racing Turbo on our website, and that dude had a 67 millimeter compressor wheel. There's 11 choices. He's got a whole bunch of them over there. That was V-band, wasn't it?
Was it T4?
No, I think it was V-band on that thing. Okay, now he's got 762. So he's actually opened up his selection since then. So on the 67 millimeter inducer, we started off with 62s, which are small. And he's now got 66 and 68 millimeter turbine wheel options, but these happen to have a 62. And they were V-band. All right, what I think it was a VS Racing part number VSG-S0005. It is a $699 turbo. I do want to talk about VS Racing here a little bit. A lot of people use these turbos. He did a really great job with these turbos. They're made in China, but he knows turbos well. He spends the time to help people when they had problems, right? There's a lot of things that can happen with turbos in terms of the drains and the cruddy fittings some people try to use where they're starving the turbo for oil, or they're getting too much oil and they're blowing oil. He really did a lot to, when he started his company, really babysit customers to help them when they were having a smoking turbo to solve the problem. So he rose above and beyond a lot of folks, and we brought him on here at Summit Racing really as our first, fairly inexpensive line of turbos.
Right, yeah.
You know, we had Turbonetics, we had Precision, we had a bunch of really great turbo brands, but VS came in at a very low price point. And with this type of engine, we wanted to have a low price point turbo on it. 67 millimeter is right sized for a 408, making this type of power, but a 62 millimeter turbine is not. That's a heck of a lot of cubic inches. And again, those last few pounds of boost to hit that 1202 number, you could just see the pipes, they were glowing red. Maybe get into that a little bit. I mean, yeah, pipes glow red anyway, but the turbine on that
was running out of turbine.
It was running out of
Yeah.
turbine, right? And a lot of people don't really think about this thing, but they think about turbos by inducer size. They really need to start thinking about turbos by exducer size. What is basically meaning on the turbine side? They really need to realize that unless they can get it out of the turbo, what they're trying to press in on the compressor side isn't flowing. It's mass flow through the engine, and that is an indicator of boost. So when you put a higher flowing hot side on this thing, your boost may drop, but you're going to be making more power. So that's why 18 pounds of boost on your, Honda Civic is very different than 18 pounds of boost on something with a T6, a big turbine.
Dump truck turbo, right?
Right. So at any rate, going back to Mike's comment on, we were trying to, as soon as the dyno was going to be able to catch this thing, we wanted to get some torque numbers down to 2,500, and that wasn't going to happen because when we'd start loading this thing in, those turbos would go, whoosh, and they were in boost now. And it was putting so much, and we didn't have any timing on those early runs either.
Right.
I mean, we were putting so much power and torque through this thing at low RPM that we were boiling the water in the brake on the dyno. And when the water on the brake boils, it can't hold anymore, and it would go woo like that, and you'd lose control of the motor.
Yeah.
And our friend Joel was very quick on the throttle stick over there to be able to catch it. It's pretty exciting to watch. But what we ended up having to do is go pretty light on the boost and timing at 3,500 RPM, even really, really light. We were making 1,136 foot-pounds of torque.
Something like that, yeah.
At 3,500, it was ridiculous. But even at 3,500, we couldn't do a real sweep because this thing wants to spin 7,000 or more. So we would start the pull later on in life. I
You
think
ended up starting at
4,600.
4,500, something
Right.
like that, and go 45 to 7 or whatever.
Just to give the
yeah.
water, enough time to control it that we could see what that peak number was. But yeah, we've never had a dyno pull where we could really push the bottom of the curve and the top of the curve at the same time. We've got a lot more turbos now than we used to have even a few years ago.
Right.
Should talk about that a little bit. We have our 2600 series turbos and the 2700 series turbos. Mike and I and Summit, we're not going to put our name on something unless it's really good. We're not going to go out there and sell people parts that are going to have failures. And so it took us a long, long time before we were confident with Chinese turbos that we knew and we could trust to be right and not cause problems, because you know that we stand behind what we sell and we race what we sell what we race. So he brought on the 2600 line of turbos, and soon after that we created our 2700 line of turbos. Those are made by our friends up in Canada that make really, really awesome turbos. And we buy a bunch of these really highly developed turbos in big production runs, and that brings the price down. So you're getting, with the 2700 series turbo, you're getting a boutique turbo at a mainstream price. I want to probably bring up our 92 millimeter turbo, Summit Turbo.
We should have had some on the table out here.
Should have put our big turbo out here.
Yeah.
So again, going back into navigation on the left-hand side of our website, Summit Performance Turbochargers. If you ever look in images, by the way, because we do try to make it easy for people to find stuff, if you go into catalog images, you're going to see that we've got every turbo that we sell listed from small to large. From, basically we do go off inducer size on this thing, but the 92 millimeter T4 that we put on JP's ride is a S492, is what we call it. That is the SUM-270-112R, and that is a bad, bad man. I probably can't say that it's the most powerful T4 in existence, but it might be.
It's in the hunt.
Yeah. And the reason why is we were basically putting a T6, a big 92 millimeter compressor side on a T4, and the only reason we can do that is because we have fitted a T6 sized turbine wheel inside of a T4 housing. That housing takes a lot of precision machine work and modification to fit that big of a turbine wheel inside of a T4 housing. But it is sturdy, it works, and it flows like crazy. We rate that turbo, that 92 millimeter turbo, at 1,150 to 1,450 horsepower. Turbo horsepower numbers are kind of new for us too. We had an aversion to that when we first started doing this gig, because you could take any of these turbos and put them on a 2JZ and they're going to do one thing. You go put that on a 454 and it's going to do another thing. And the smaller engine is actually going to be the one that makes more power until it blows up. So what we did this year, because people have been asking for horsepower ratings, we're like, okay, we got to do this. So we settled in on a 5.3 or 6 liter LS engine, because that is 90% of the people who are buying these turbos from Summit Racing. The other thing is that, as Mike commented, you know, what transmission is a guy going to be running behind these things? They're going to be running a Turbo 400, and they're going to be running a loosey-goosey stall on it. So these horsepower ratings are going to be numbers that you are going to be able to replicate on your 5.3 or 6.0 without any weirdness
A lot of
to it.
exotics. No, not a lot of
Exactly.
exotic
These are
parts.
really bargain, you know, engines, just like a rod, a piston, a cam and spring type of deal, nothing exotic. So these horsepower ratings that we've got on these turbos now, you're going to be able to hit that like no problem. The other thing is JP, I think he hit JP. He's worth a live stream in himself, but he puts this thing in his 3,100 pound RX-7, got a stock T56 in this thing, and JP don't spend money on going fast. He can drive like the Dickens though. He puts this thing on a 6 liter, and he puts the thing on, what did he break? He had it on a 6 liter.
didn't he?
It was a stock engine, and the thing made 1,000 horsepower like nothing. He ran 880s at 163 with this thing at 26 pounds of boost, which to a lot of people that sounds like a lot of boost. It is not. That turbo is really just entering its sweet spot around 26 pounds of boost. So do not be afraid to go 38 or 40 pounds of boost with a lot of our turbos, especially the 2700 series turbos. That VS Racing that we ran, it was out of power at 27 pounds. Again, completely different turbo and application. But do not be afraid to run a lot of boost with our 2700 series turbos. The other thing is that a lot of people don't talk about this, but it's really easy to mismatch a turbine and compressor and really overspin a compressor in the search for power, and that can really kill reliability. We will not match a turbine to a compressor. That's a big mismatch that's going to cause reliability and shaft overspeed. We just don't do it. There are some people that will do that to sell you a turbo. We don't. We just, you know, it's not worth your time or ours to have to deal with parts that are breaking. So especially on a 2700 series part, like I said, it's a boutique level turbo, and believe me, there's people spending $6,500 or $8,500 on a turbo on a, you know, small tire car or something like that, that they're probably going to be getting outran by a $2,000.
We probably need to do a whole nother live stream on
Yeah.
turbos and turbo manifolds and wastegates and all the goodies we've got for that stuff.
Is that
so.
Mike telling me that we got to get off the horn?
Pretty much. Yeah.
All right. So what else about project? I'll ask you this. What's next?
I think what's next is we've got some new aftermarket engine blocks coming out that are very exciting. They're cast in Germany, machined in the United States. The quality of the metal is out of this world. We've got small block Chevrolets right now. I've got small block Ford and big block Chevy coming, and there is an LS in the pipeline. So I'd like to reblock that Project 1000 and see what we could do with some other turbos.
All right. I wasn't going to let
Rotate the world,
cat out of the bag,
but,
but all right. So here's the thing about Summit Racing. Like I said, we're not lacking in resources, right? And there's a right way to and a wrong way to do things. So we have seen that finding good cores has become impossible.
It's getting there. Yep.
Right.
So.
And Dart does a pretty good job with their blocks. A lot of people have run the LS Next and everything like that. That's a good.
And their SHP stuff's real nice.
Yeah,
too.
yeah, and we use that on a lot of stuff. So we like the Dart SHP. We wanted to have something that was more of a value, I think. But
Well, we want to
out,
secure our future of the industry and our company, and having parts to support our hobby and our industry. So yeah.
all right, so that's the best way to phrase it. Is yeah, we're concerned about things drying up there, and Summit Racing, we are going to be here until the end of time when it comes to internal combustion engines, and the best way for us to do that is to spend a lot of money now to make sure that we have got stuff for you guys to be building long into the future. A lot of people don't think about this, but even Gen 3 and Gen 4 LS stuff is drying up. Even now, it's drying up. people are having to use LT direct injected engines.
It's 20 years old. Gen 3 is 20 years old.
Right, in
Hasn't been made in 20 years,
1997.
yeah.
Right, 97 for Gen
So-
3. So again, Mike, you guys could have just had something that was cast in China. We didn't. It's cast in Germany, and it's awesome. And if you drive a Chevy truck or a GMC, there's a good chance that it has a lot in common with this engine block in terms of where it was cast and the individuals that cast that block. And the first time I saw this block, I'm like, holy awesome. This thing is, the detail on it, I'm pretty stingy with a lot of things. I'm like, oh my gosh, they really thought about this thing when they designed it. We work with a really good partner here in the States that does all the machining on this thing. So this ain't no China block. This thing is a very, very high-end block. I think it's really, I could say it's the best on the market. I'm gonna go ahead and say that.
It's going to be pretty awesome.
Pretty
Yep.
awesome. So we've got those things, and again, we've got the rotating assemblies to match. Crank rods and pistons, you're gonna see a lot more of that over the course of 2024. Heads, valve train, got it all. We're gonna
Gonna
boost
be
it all.
lots to look for. Yep.
I've gotta go and make more parts. All right,
I'm out.
I'm out. All right, rock and roll, guys. Thank you
Thanks.
very much for joining us. And if you have any questions, just put them down in the comments, and we'll do our best to address them as we can. Thank you very much.